Let us understand how to autoscale a Kubernetes application as per the pending messages in a PubSub. We use a PubSub to free up the message producing application from the message consumer. That means these applications can work independently. The first scenario is, suppose the publisher and subscriber are fast enough so that whatever messages are published can be consumed by the subscriber easily. In that case, there's no problem, it's the ideal scenario, and our setup is fine. The next scenario is, suppose our publisher is faster, but our subscriber takes so much time to process the message. In that case, there will be a backlog of messages in the PubSub. This won't be a proper scenario since we need the data as soon as possible for further processing. Next scenario is, we have a faster publisher, but we have a scalable subscriber application. In that case, if messages increase in the PubSub, our application will scale up and consume those messages and finish the pending messages faster. And this is the scenario we are going to demo. For this demo, we'll have a cloud PubSub topic, a GKE cluster. We'll deploy a custom metrics provider, a subscriber service, and a host.pod autoscaling setup. Here we are going to see how to autoscale our Kubernetes pod according to a custom metrics from the GCP PubSub. So for that, first what we need is to create a PubSub. I have created the PubSub. Its name is test topic. Then created a subscription for that one. That is the test topic sub. Here, a few changes. What I have done is the acknowledgement deadline I changed to 20 seconds, and message ordering is enabled. These changes are done so that message will not be processed very fast and we can see the auto scaling happening. That's the only reason I changed these parameters in the subscriber. Next, what we need is a cluster. Here is the GKE cluster. I have created an autopilot cluster. The autopilot clusters will allocate resources as per our need. That means when we deploy a pod, for that pod, how much resource is required, accordingly, it will allocate resource. In autopilot cluster, by default, workload identity is enabled. If you know how to set up the workload identity, I have another video. The link is given in the description. You can check that out. Workload identity is used to give permission for the Kubernetes service account to access other resources in the Google Cloud platform. Here what we are going to see is our application should autoscale as per the pending messages in the PubSub. That means it has to check the stack driver metrics and autoscale our pods. For that we need a custom metrics adapter. Google already provides a custom metrics adapter. Here are the steps to set up the custom metrics adapter. We'll set the project ID. Then this is the workload identity setup for the adapter. That means it needs some permission. It has to pull metrics from the stack driver. So for that, we have to run this to set up the workload identity for the adapter. Then we'll deploy the adapter. I have already deployed it. You can see it here. We have the custom metrics stack driver adapter and it is running fine. Now let us see our application. Our subscriber application is a simple application. It will take the subscriber name from the environment variable. Then we have the message receiver. We are creating the subscriber and adding the message receiver to the subscriber and starting the message reception asynchronously. And we are saying until termination, continue running it. This is the function where we'll get the message. First thing what we are doing is we are waiting for 10 seconds for each message. That means once we receive the message, we'll wait for 10 seconds because we want to slow down the message processing and we can see how the ports are auto scaling. Then we acknowledge the message. Here is the deployment manifest file. Here image is pulled from the Docker repository. This is my repository and this is the image tag. And we have seen that we are using an environment variable to pull the subscriber name. That's also set here. This is the subscriber we have created in PubSub, and its full name is given here, and these are the resource requirement is not relevant here. Next one we have to look into is the auto scaling setup. This is the horizontal code autoscaler manifest file. Here we are saying that the scale target is the deployment. Its name is qpubsub. Minimum replica is 1, maximum replica is 5. Then this is the external metrics we are setting up. Here we say metrics name is this one, pubsub googleapi.com subscription. In that, number of undelivered message. This is the metrics name we are going to use. That means how many undelivered messages are there. Accordingly, scale up or scale down our ports. Here the average value, if it's 2, then start scaling up. If it's less than 2, scale down. And the subscription ID is, this is the ID of our PubSub subscription that we created. Here are the scale up and scale down behaviors. For the scale down, we are saying that stabilization window is 60 seconds and percentage is 100%. Then the stabilization window for the scale up is kept at 0 to make the scaling up faster. Then we have two policies here, 100% or 4 ports at a time, and whichever is the maximum. That way the rule will be applied. Now let us deploy our application. I have my manifest files here. Code is running now. Let us check the logs. We don't have any messages, that's why there's no messages getting displayed here. So let us push some messages. You can go to the topic, go to messages and publish messages. I'm going to publish 100 messages. Every 1 second, one message will be pushed. Started pushing the messages. Let us say our subscriber service is accepting those messages. You can see the messages are getting received by the subscription service. Still only one port is there. There is no auto scaling setup so far. Let us deploy the auto scaler. So horizontal port auto scaler is set up. Now let us watch the Kubernetes ports. So far only one port is available. Still messages are getting published. Let us wait. By the time, let us see our workloads. We can see two ports are there. One is the custom metrics, the stack driver adapter port, which will pull the metrics for our service. Then this is our service. We can see that horizontal port autoscaler is deployed okay, and it is working fine. Let us wait for some time. We can see that ports are getting autoscaled. If you are interested in learning Kubernetes in depth, you can check out the training link provided in the description.